Welcome back. This is the last little bit of our unit with simplifying and verifying trig identities. This lesson is for half angles. It's the second part of the double half angle formulas. Alrighty, so our half angle formulas. Remember, this is sine of half of an angle, and that x is always going to represent the original angle value. What are we taking half of? Okay, so for sine of a half angle, it is positive and or negative, depending on where it is, 1 minus cosine of x, the original angle, all over 2. For cosine of a half angle, okay, very similar formula. It's positive or negative square root of 1 plus cosine of the original angle all over 2. We do have tangents that we can use. Now you can just take the sine formula and divide it by the cosine formula. There is absolutely nothing wrong with that. Or we can use 1 minus cosine of the original angle over sine of the original angle. Or we could do sine of x all over 1 plus cosine of x. We probably won't do as many of the tangents as we will sine and cosine. And our quick note, be really careful with your answer. You have to determine where the half angle lies. Now, if you already know what the half angle is, you already know what quadrant it's in, so you can very easily determine if you need the positive or the negative answer. It's never both. All right, number 1, find the exact value of cosine of 15 degrees. Okay, so first thing, I got to find the original angle. So 15 is half of what? Okay, well, really easy. Take the angle and double it, and that gives you the original angle. So 30 degrees. That's what I got to know. First things first. The next thing I need to know is after I get what the half angle value is, I need to, in this example, do cosine of that value. So what is cosine of 30 degrees? Perfect. It's the square root of 3 over 2. Okay. And the next part you can do is, where is your half angle? 15 degrees, that's in quadrant 1. What do we know about cosine in quadrant 1? It's positive. So already we have eliminated a lot of headache trying to figure out, is it a positive, is it a negative answer? Okay, so cosine of half of x equals, in our case, positive, I'm just going to write the formula, plus or minus the square root of 1 plus cosine of x all over 2. But again, we are doing cosine of 1/2 of 30, which we know is going to be a positive answer. So it's the positive square root of 1 plus cosine of 30 degrees all over 2. Well, we already know cosine of 30 degrees. That is the square root of 3 over 2. So this equals the positive square root of 1 plus the square root of 3 over 2 all divided by 2. Okay, now remember, when you divide by 2, it's equal to multiplying by 1/2. So all the stuff underneath the radical, the 1 plus the square root of 3 over 2, is all really being multiplied by 1/2. So 1 times 1/2 is 1/2, and 1/2 times root 3 over 2 is a square root 3 over 4. So however you choose to simplify, whatever makes sense for you. You could also just do 1 divided by 2, square root of 3 over 2 divided by 2. Whatever works for you. But we are now going to rewrite that this equals the positive square root of 1/2 plus the square root of 3 over 4. Get a common denominator. So you have 2/4 plus the square root of 3 over 4 under your radical. And since they now have the same denominator, you could write it as 1 fraction, 2 plus the square root of 3 over 4. Now I'm going really in detail with this. There are several steps that you can skip. Okay, if you see it, you can jump to get to other places. And then this last part, the numerator and denominator are both under the square root. So you could separate the numerator under the square root divided by the denominator under a square root, giving us our final answer, the cosine of 15 degrees equals the square root of 2 plus the square root of 3 all over 2. That's your final answer. Now, sit on that one for a minute before you move on to the next example. Press pause, look through, make sure you got everything down pat. Okay, great job. We're moving on to our next one. Sine of 22.5 degrees. Okay, so to find our original angle, since this is a half angle, I've got to do 2 multiplied by 22.5, which gives me 45 degrees. Okay, again, that angle is in quadrant 1 and sine is positive in quadrant 1. So I've got my info that I need. I've got the measure of the angle, I've got the quadrant that its half angle is going to be in, and I know it's going to be positive. And then the last step is what is, in this case, sine of 45 degrees. Evaluate the original angle. That's right, it's the square root of 2 over 2. Okay, so moving along, here's our formula. Sine of 1/2 x equals positive or negative square root of 1 minus cosine of the angle all over 2. Let's substitute in our specifics for our problem. 1/2 of 45 degrees, sine of that is going to give us a positive square root of 1 minus cosine of 45 degrees all over 2. Oh wait guys, we need cosine of 45. That's okay. Cosine of 45 degrees is also the square root of 2 over 2. Not a problem. Okay, now we can simplify. Square root of 1 minus cosine of 45 is square root of 2 over 2. That's all still divided by 2 under the radical. Remember what we did the last time? We took 1/2 and multiplied it by 1 plus or minus whatever's in the radical so that we could have that all simplified. So this next step is the square root of 1/2 minus the square root of 2 over 4. Okay, again, get your common denominator. If you need to see that step, it would be 2 over 4, and then minus the square root of 2 over 4. Write them as one fraction. Then you can write your numerator under the radical divided by the denominator of the radical, being, the square root of the denominator also. So we can state that sine of 22.5 degrees simplifies to give us positive square root of 2 minus the square root of 2 all over 2. No, none of the 2's can reduce because they're under radicals in the numerator and not in the denominator. Alrighty, number 3. If 180 degrees is less than theta less than 270 degrees and sine is negative square root 5 over 3, find the following. All right, we got a little bit to do with this one. So 180 to 270 is quadrant 3. Okay, so sine of our original angle is negative square root 5 over 3. They've already given us that. I also need to know if sine's negative there, then half of that angle of sine. Is it going to be positive or negative? Okay, so half of 180 is 90 and half of 270 is 135, which puts me in quadrant 2, and sine is positive in quadrant 2. Okay, good. Now, they didn't tell me cosine, and for cosine I need for the half angles I need the cosine value as well. So negative square root 5, 3 are my values for sine of the angle in quadrant 3. I need the x to get my cosine of theta. So let's see, that would be x squared plus y squared equals the hypotenuse squared. So x squared plus 5 equals 9, x squared equals 4, so x equals 2. So our cosine value is actually going to be negative 2 over 3. I need that ratio to use to evaluate. All right, so sine of a half of theta, whatever that angle is, we don't really know. It is, in this case, again, it's still positive. We figured that out at the beginning, so it's the positive square root of 1 minus cosine of theta, so minus a negative 2/3 all divided by 2, which is 1 plus 2/3 all over 2. Okay, now we can go ahead and write that. 1 plus 2/3, that's 3/3 plus 2/3. So that would be the square root of 5/3 divided by 2. And if I take 5/3 and multiply it by 1/2, I get 5/6 under the square root. Okay, so that answer is good. If you are asked to make sure it's in simplest terms, you would want to rationalize, so you'd have square root of 5 over the square root of 6, and we would multiply through by the square root of 6 in both numerator and denominator, simplifying to give us the square root of 30 all over 6 for sine of that half angle. Whew, that was a doozy. Alrighty, we've got a couple more. Let's do the next one. 180 degrees to 270 sine. Oh, it's the same information. Okay, good. So we have the same information. We already know that sine of theta is negative square root 5 over 3, and we determined that cosine of theta is, that was negative 2 over 3, negative 2 over 3. All right, now the thing that we have to do is determine, because this one is for cosine, we have to determine if cosine is going to be positive or negative. So between 90 to 135 degrees, that's half of each of those. That is quadrant 2, and we have cosine is negative in quadrant 2. So in this one, when we do cosine of our half angle, half of theta, we're going to write the negative square root and then do our formula. 1 minus cosine was negative 2/3 all over 2. Now we've already simplified all this, guys. So that's negative square root of 5/3 over 2, which is the negative square root of 5/6. And we already did all that work in the previous problem. So when we rationalize, we will get the negative square root of 30 all over 6. And that is for cosine of this half angle. Great job. Alrighty, last one of these, just to show you a tangent example. It's the same problem. So we already have sine of the angle to be negative root 5 over 3. We also have cosine of the angle to be negative 2 over 3. Now we need to talk about tangent in quadrant 2. Okay, well, in quadrant 2, x is negative, y is positive, so that's going to make tangent negative. Alrighty, we got it. For tangent, we have those two different formulas, and we're going to use the one that's easier for us. We have 1 minus cosine of x divided by sine of x, or we have sine of x divided by 1 plus cosine of x. All right, so it truly doesn't matter. I'm going to choose to use the one that puts sine in the numerator because it has a radical. If it didn't have a radical, it wouldn't matter one bit. All right, so let's process through tangent of a half angle for this example. Again, that's going to put us in quadrant 2 for tangent, which will give us a negative answer. It should work out to be negative. And we are going to use the formula sine of x, negative square root 5 over 3, divided by 1 plus cosine of x, which is a negative 2/3. Okay, we just got to clean up the mess here. So 1 minus 2/3, that's 3/3 minus 2/3 is 1/3. All right, so this equals negative square root of 5 over 3 divided by 1 over 3. That's tangent of the half angle. Okay, hey, this one's not too bad actually. The numerator and denominator have the same denominator. So when we multiply by reciprocal, we would end up getting a negative square root 5 over 1, which is just negative square root of 5. Hey, Great job, right at the 15-minute mark, just like we like it. Make sure you guys are practicing again, and you've got several days you can practice before we have our assessment. Have a great one. Let me know if you need any help.